So first of all, I bought this adapter, this one here, the $3.87 one. And it looks like this. So it's supposed to be 120 watts. And it says on here 20 volts, 3.25 amps. And that says 12 volts, 5.4 amps. So it's claiming that that's what it can produce, right? So then, and it has 2 ports on here, okay? So notice one thing right away. So if I unplug it, you'll see that it charges my power bank on the 5-volt line. But when I plug this in, it automatically turns my 5-volt line off, the 5-volt power bank. So it only can charge one at a time. If they're at the same voltage, they could charge multiple. But so then the second thing is.
So basically, the only reason for having a second port is to have 2 options for the USB sizes.
I suppose.
Did it claim that it was going to charge both at the same time?
It didn't really say. It just says 120 watts. But the thing is, it says 120 watts. But if you plug this in and get the max power you can, which is the 20 volts out, then that means you'd have 20 volts at 3 amps, which is only 60 watts. So there's no way you're even getting close to the 120 watts. And the only way I knew that is because I'm using. So then I got, this is like a decoy board. It acts like a phone and it requests it to put out voltages and stuff. So this is like this basically pretends like it's a power device. And then this one is a little booster board that boosts the signals so that this logic analyzer can read the signals. So what I'm going to do is I'm going to show you what the signals are. Okay, so this basically reads the signals that are being sent between this little board and the power supply. So this board will send the signals through this board. So what I'm going to do is I'm going to plug it in, and right before I plug it in, actually, I'll unplug this one. So right before I plug it in, I'm going to press play to record what's coming through. Boom. So now here's what's actually is like the data, okay, on the big screen. So we said, this thing said it supports 20 volts at 3 point something amps, 12 volts at 5, 4. Well, this is the device, and it says source here. And so that means that's the source is your power adapter. And then the sync SNK is your phone or whatever is requesting power. So that's how you know which one's which talking. I think it's got it color coded, so orange is the your power device that wants power, and then pink is the one that's the actual plugged into the wall. So if you look at here, it says 5 volts 3 amps, 9 volts 2.2 amps, 12 volts 1.67 amps. And then it says, and these are the ones and zeros right here, all of like the data being passed. Okay, and it's this software interprets it. So this 3.3 to 5 volts at 3 amps, 3.3 volts to 11 volts at 2.75 amps. So you can actually do variable voltages called PPS. It's programmable power supply. So just really quickly, by plugging this in and reading this data, you can see that 120 watt adapter does not support what they say it supports. What do you think about that? So, I mean, that's how I found out this other, I've been going through different chargers and reading the information it's putting out, because basically you can only draw as much power as it's advertising. Your device is never going to draw more power. So right here is 20 watts. And so that's your max. The max you're going to get out of that thing is basically 20 watts, even though they call it a 120 watt adapter. So maybe the one in front means it's a 120 watt adapter, not a 120 watt adapter. So basically
So is that really 1/6 of what it says?
Yeah.
Is it ratio like that?
No. It's, what do you mean is a ratio like that? They put whatever they want on there. They could put it, so say it's a 1,000 watt adapter. And unless somebody goes after them.
So it's not like it's half of what it is. It's literally a sixth of what it is.
Yeah. Yep.
So how long would it take to charge your phone compared? Would it take literally 6 times as long to charge your phone?
So this would be more for like if you were going to use your laptop on it or something. So it could probably charge your laptop. I've accidentally charged my laptop through one of those before. I mean, it takes forever. Like, you come back the next day and it'll finally be charged.
Where'd you get that piece of junk?
So I got it from this AliExpress website.
You have heard the saying that you get what you pay for, right?
Well, that's sometimes the case. So for $3.87, I thought I was getting a 120 watt adapter. But this is why I'm doing this, because I want people to know like a lot of these are fake clones.
I think I paid more like $18 to $25 for microphones.
Yep. Yeah, you're probably gonna pay more like that for a nice one. So that's why I'm gonna keep trying them out until I find a really cheap one that's actually as good as it says it is. So yeah, so we've taken this thing and looked at the PD data and looked at, it can't actually put out 120 watts. So now what I want to do is actually look at the parts inside to see, what kind of parts do they even have that they put this claim on here that they could put 3.25 amps out when it only says they can put out less than an amp at 20 volts or about an amp. So, and since it's about a 20 watt charger. So let's quick pop this open. So I've kind of had to break the seal open before, and that's why this looks so bad. But now, right away, kind of interesting, you see there's some aluminum metal here, and then there's a circuit board, and then there's two jacks here. So let's pull this out if I can. Okay, so inside there, very similar to other adapters we've seen. Basically, these little pinchy things go down there and make contact with your input, and then your metal is probably just for heat dissipation. Yeah, so here's the board. So you have some main chips on here, okay? Now, you have your input rectifier to make it from AC to DC, so that's your BD1. You got a kind of an input fuse type of thing, your input caps, and then some output caps. Now, interestingly enough, they have the secondary circuit board here, and basically this circuit board here is where your USB-C chip is on it, and so the USB-C chip is the HC2827AC, and I'll show you that. And then you have 10 microfarad capacitor, output caps. This is your optocouple feedback right there. This is your actually switching chip. It's controlling everything. And your switching chip is the HC2608. We're going to look at the data sheet for that. And then also we've got one more chip here. And this chip here is for rectification for your flyback. So you've got your transformer. You always have to have a flyback rectification chip or diode. So to make it more efficient, they used a chip. And this board is soldered in. So it's like a circuit board on top of a circuit board. All right, so we talked about the three different main chips. And let's go through first for the switcher chip. That's the controller, and that's a 26008. So that's this chip here. This is the reference schematic. So we got this rotated, and this is the schematic for what's in the 2608. And basically we have, as you can see, AC, line in, and neutral. So your 120 volts or whatever. And then there's a fuse, like we saw that little resistor looking thing. And then we have input filtering, and then there's the transformer, which we saw, and then also there is a, here's your actual switching chip, which is the 2608, a optocoupler so that it's light, and that gives you your isolation so that your high voltage on your input side and then your output voltage are not any way referenced to each other. They're isolated by this LED and photodiode optocoupler. And then you can have, on the output, you have D plus, D minus, VD, and ground, all this deal. And that's not what we actually have, because they replaced this chip. Instead of having this 6602, they used the 2827. So here's your 2827 chip that they used as a negotiation chip. Now let's scroll down to the example circuit. So you have power in, which is, this is the power that's coming from your switching chip. So this power right here, V power, is the same power as going to be right here on the output of this diode. Okay, so this power here goes into the chip, VN powers it, and then also feedback. Now the feedback here is going to be connected to the 2608, which is through this optocoupler. So you have the optocoupler, you have the 2608 on this side, and then you have the 2627 USB-C side there. So you have that, and then interestingly enough, so remember how when I plugged in my power bank to the USB-A port, it automatically shut down when I plugged in power to, or wanted to charge something on the USB-C port. And that's because the USB-C port wanted to negotiate a higher power negotiation and higher voltage. And when it did that, it had to disconnect using, so let me zoom back in a little bit. So this is your D plus, D minus, and that can negotiate with this thing. But then, and basically this is like a switch, acting like a switch, so that this will not negotiate any other power rating or anything else. It'll just leave it off and you won't get any power out of it. So that's how they're getting this, where this voltage here on this line going to V-bus and this V-bus are all the same, except for the fact that they could turn one or the other off. So I kind of find that very unique. Although it's unfortunate, because then what ends up happening is you can only charge one device at a time if one device wants a higher voltage. So it's very simple. And then finally, there's one more chip we said is a rectification chip. And that's basically, it says it's a synchronous rectifier. And basically, in this schematic, it would replace the D2 for this rectification. So there's not a lot of components in here. It's a very simple charger. It was a nicer one than the last one we did, the 65 watt, but still it's really not a very high quality charger, and it's fake because it says it's 120 watt, and in practicality it really can't get 120 watts. You could buy it for $3 or $4, but don't get your hopes up on what it can do. So stay tuned.